So this is the team of Americo and Emmanuel, and we are going to talk about idef0. What is the idef0? idef0 stands for Integration Definition for Function Modeling. And why is modeling? During the 1970s, the US Air Force program for integrated computer-aided manufacturing sought to increase manufacturing productivity through systematic application of computer technology. The ICAM program identified the need for better analysis and communication techniques for people involved in improving manufacturing productivity. As a result, the ICAM program developed a series of techniques known as the idef techniques, which included the following: the idef0 used to function model, idef1 used to information model, and idef2 used to dynamics model. idef0 is a modeling technique based on combining graphics and text that are presented in an organized and systematic way to gain understanding or support systems level design and integration activities. An idef0 model is composed by a series of diagrams that gradually display increasing levels of detail describing functions and their interfaces within the context of a system. There are three types of diagram: the graphic, the text, and the glossary. And the graphic define functions and functional relationships via box and arrow syntax and semantics. The text and glossary diagrams provide additional information in support of graphic diagrams. idef0 is an engineering technique for performing and managing needs analysis, benefits analysis, requirement definition, functional analysis, system design, maintenance, and baselines for continuous improvement. The idef0 model reflects how system functions interrelate and operate, just as the blueprint of a product reflects how the different pieces of a product fit together. The components of the idef0 syntax are boxes and arrows, rules and diagrams. Boxes represent functions defined as activities, processes, or transformations, just as the image represent. Arrows represent data or objects related to functions, do not represent flow or sequence as in the traditional process flow model. Rules define how the components are used, and the diagrams provide a format for depicting models both verbally and graphically. So this is how a semantic is represented. Box meanings are named with verbs or verb phrases. Arrow segments are labeled with nouns or noun phrases to express meanings. Each side of the function box has a standard meaning in terms of box-arrow relationships. The side of the box with which an arrow interfaces reflects the arrow's role. Arrows entering to the left side are inputs. In the up side of the semantic is used for controls. Controls specify the conditions required for the function to produce correct outputs, and in the right part of the function are the outputs that are the data or objects produced by the function. In the bottom side of the box represent facing upwards represent the mechanism, and mechanism arrows that point downwards are called arrows. Call arrows enable the sharing of detail between models that are linking them together. Diagrams. The graphic diagram is the major component of an idef0 model. Boxes represent each major function of a subject. These functions are broken down or decomposed into more detailed diagrams until the subject is described at a level necessary to support the goals of a particular project. Top-level diagram. Each model shall have a top-level context diagram. It is called the A0 diagram. The statement of purpose expresses the reason why the model is created. The most important features come first in the hierarchy, as the whole top-level function is decomposed into subfunction parts. Parent diagram. A parent diagram is one of that contains one or more pattern boxes. Every ordinary non-context diagram is also a child diagram, since by definition it details a pattern box. Thus, a diagram may be both a parent diagram and a child diagram. Likewise, a box may be both a parent box and a child box. The primary hierarchical relationship is between a pattern box and the child diagram that details it. Diagram features. Arrows on an idef0 diagram represent data or subject as constraints. The arrow connecting to a box represents all the data and objects that are needed for the function to be completely performed. Concurrent operation. When an output of one box provides some or all of the inputs, controls, or mechanisms needed by another box, a given activation of the latter box may depend on sequential performance. High-level arrows have general labels, while arrows on lower-level diagrams have more specific label. In an arrow splits, forming two or more new arrow segments, each arrow segment may have a more specific label. An arrow may branch for join, indicating that the same kind of data or object may be needed or produced by more than one function. The branches may represent either the same thing or portion of the same thing. A forking arrow may denote the unbundling of meanings that have been combined under a more general label. Boundary arrows on graphic diagram represent the inputs, control, outputs, or mechanism of the diagram's parent box. The source or use of these boundary arrows can be found only by examining the parent diagram. All boundary arrows on a child diagram shall correspond to the arrows that connect to its parent box. ICOM codes relate boundary arrows on a child diagram to arrows connected to its parent box. A specific notation, called ICOM codes, specifies the matching connections. The letter I, C, O, or M is written near the unconnected end of each boundary arrow on the child diagram. Using the letter numbering matching scheme of ICOM coding, arrow rows may differ between pattern and child diagrams. A tunnel arrow is used to provide information at a specific level of the composition that is not required for understanding at some other levels. An arrow can be tunneled at any chosen level. Using the parenthesis notation, tunneling an arrow where it connects to a box side means that the data or objects expressed by that arrow are not necessary for understanding subsequent level of the composition, and thus shall not be shown on its child diagram. Some diagram syntax rules. Context diagrams shall have node numbers an, where n is greater than or equal to 0. The model shall contain a A0 context diagram, which contains only one box. The box number of the single box on the A0 context diagram shall be 0. A non-context diagram shall have at least 3 boxes and no more than 6 boxes. Diagram reference expressions. Reference expressions use codes that are assigned to model features such as diagrams, boxes, arrows, and nodes. Reference expressions then can be used in various contexts to reference precisely to any aspect of the model. Box numbers. Each box on a diagram shall be numbered in the lower side right corner of the box. This numbering system is required to unquietly identify the boxes within a diagram and to generate node numbers. The node number is based on the position of a box in the model hierarchy. Normally, a node number is formed by appending a box number to node number of the diagram on which it appears. The node index is a representation of node information in an outline format. All node numbers along with either diagram titles or box names shall be presented in an intended form that exhibits the nested hierarchic structure of the model. The node tree. The developed idef0 model with its structure decomposition provides the basis to sketch the full decomposition in node tree fashion on a single large diagram. The content of the node tree shall be identical to that the node index or any suitable portion of interest. One of the most important features of the idef0 as a modeling concept is that gradually introduces greater and greater levels of detail through the diagram structure, compromising the model. In this way, communication is enhanced by providing the reader with a well-balanced topic with a manageable amount of detail to learn from each diagram. The diagram in which the A0 top box appears represents the context of the model and is called a context diagram. The minimum context for a model is a special context diagram with the node number A0. The A0 context diagram has only the single name A0 top box with its labeled external arrows, and also textual definitions of the viewpoint and purpose of the model. Model description. High-level context diagrams have node numbers for the form AN for n greater than 1. By providing a more complete description of the model's environmental context, not however intended to be definitive in all respects but only typical, context modeling, characterized by negative node numbering, provides more constraining specifications on the boundary conditions of the A0 diagram of the model. The node numbering scheme provides the basics for coordinating the FEOs, text and glossary terms. During development, it is important that each new element of information be associated with the node that brought it into consideration. For each form, FEOs, text and glossary, the node numbering extension notation consists of a single letter appended to the associated node number. Some presentation rules. When there is text, it shall accompany the associated graphic diagram. In non-publication models, the glossary associated with a specific graphic diagram shall accompany the diagram and shall define only the keywords, phrases, and acronyms used with the particular node. In publication models, a glossary section shall define the keywords, phrases, and acronyms in alphabetical order for the entire model. When a table of contents is provided for a model, it shall be represented as a node tree or node index and shall contain node numbers, diagram titles, and box names. Thanks for your attention.